Hello everyone, welcome to Equal To, and this is the 11th episode of our Polynomials playlist. And in the previous video, we solved the same question with another method called splitting the middle term method. But in this video, we are going to solve the same question using a method called Factor Theorem. Okay, so Factor Theorem is something that we learned in the 9th episode of this playlist. I hope you have watched it. If you haven't, please go and check that out before watching this, because you are going to use that technique to solve this question. Okay, now with that said, let me just read the question once again. Factorize 6x squared plus 17x plus 5 by splitting the middle term and by using factor theorem. The splitting the middle term part that we have seen in the previous video, right? In this video, we are going to see the factor theorem. Okay, so let us just recap the factor theorem first. The factor theorem says that if A is a 0, if A is a 0 of P of X, okay, meaning if P of A is equal to 0, both these are the same. If A is a 0 of P of X and P of A equal to 0, both these are same. In that case, you can say that X minus A is a factor. X minus A is a factor of P of X. Okay, so this is what factor theorem says. Now again, to learn more deeply about this, go and watch that video. That is the 9th episode of this playlist. Here we are just brushing it up. Okay, so X minus A is a factor of P of X. This is what exactly or precisely we are going to use in this solution. Okay, so let that stay aside. I'll just move it over a bit. Okay, we'll have it here. Fine. So we have the polynomial 6x squared plus 17x plus 5. Okay, now what you are going to do is, using the factor theorem, you can tell that x minus a, if it is a factor, if x minus a is a factor, then P of A is equal to 0, right? And here we know the polynomial given in this question has a degree 2. Right? If a polynomial has degree 2, then it has 2 zeros. Right? This is something that we know. If a polynomial is degree 2, it has 2 zeros, meaning 2 values that can be zeros to the polynomial. Okay, so like A, there can also be another value B. P of B is equal to 0, because this is a polynomial of degree 2. So there can be 2 zeros, 2 values that when substituted brings the value of the entire polynomial to 0. Okay, so there can be 2 numbers. So P of B can also be 0. Right, so for another value also the polynomial becomes 0. So what that means is there can be another other polynomial like x minus b, that also can be a factor. Okay, so you can have two factors, x minus a and x minus b, for the polynomial 6x squared, or for a quadratic polynomial, right? Quadratic polynomial in the sense it's of degree 2. So what you can tell is that x minus a and x minus b can both be factors. Okay, now keep this in mind. Now what I am going to do is I am just going to multiply these two things just for you to know. Okay, let us multiply x minus a into x minus b. What does that give us? Now we haven't started solving the questions yet. I am just getting you acquainted with these things so that it could be easy for you to understand, right? You are going to multiply these two, so that gives you x squared minus bx, and this one, that gives you minus ax plus ab, because minus into minus gives you plus. Okay, so if you rewrite this, that gives you x squared minus a plus b into x plus a into b. Okay, minus a and minus b we have. If we take minus x as a common factor, that leaves you with a plus b, right? So x squared minus a plus bx plus ab. So if you were to have a polynomial in this form, that is x squared minus some constant into x plus some constant, if it were in that form, you can tell that x minus a and x minus a into x minus b is its factorized form, right? This is the factorized form of this polynomial. Okay, are you clear with that? Now with this said, you can get into solving the questions. Okay, you can have this in mind. It's not necessary for you to use it, but just for your understanding I have given it. Okay, so if you know the two zeros of a polynomial, here a and b are two zeros of this polynomial, right? If you know two zeros of a polynomial, you can straight away create the polynomial itself, x square minus sum of the zeros into x plus product of the zeros, that is a and b are zeros here, right? We know that. So you can straight away get the polynomial with just the zeros itself. Okay, so this is something that you can know. I think we might be covering this in the next exercise or the exercise after that. I'm not sure about it, but just for your understanding, have this in your mind. Okay, so this is there. Okay, now for you to apply those things, we first have to take this 6 as a common factor, and that leaves you with x squared plus 17 by 6x plus 5 by 6. Okay, why are we doing this? Because we know that x squared minus a plus b into x plus ab. So the constant term, you can find it only when the coefficient of x squared is 1. Okay, only when coefficient of x squared is 1, you can tell it is of this form. Okay, so that is how you are going to find this. So for that, you are dividing the entire polynomial by 6 and you are multiplying by 6 outside the brackets. Okay, or in simpler terms, you are taking 6 as a common factor. Now let us just say p of x is equal to x squared plus 17 by 6x plus 5 by 6. Let us assume this to be p of x. Okay, so this can be written as 6 into p of x. Now as you can see, this polynomial is of this form, right? And we need to factorize this. So you can express this p of x as, right, this is p of x, right? We have already seen it. This is p of x, x squared minus a plus b into x plus ab is factorized as this form. Okay, so you can just, instead of p of x, you can write it as 6 into x minus a into x minus b. Okay, because this is the factorized form and this is what they want as answer. So you are just writing it that way for simple sake. Okay, now you know the constant terms here, right? If you compare these two, if you compare this with this equation, you will know that AB is the constant term. Okay, so 5 divided by 6 is the constant term, and if you were to find the value of A by B, again you are going to use trial and error for that. To find the value of A by B, you have to find its factors. Okay, let me just erase this, we don't have enough space. Okay, so we are going to find the factors of 5 by 6. Why is that? If product of two numbers result in 5 by 6, A and B should obviously be factors of 5 by 6. Okay, so that is very basic logic. Okay, now we are going to write the factors of 5 by 6. Okay, now these factors can be, okay, let me just come to that a bit later. These factors can be plus or minus value. Okay, because we have two numbers, so you can say minus 1 by 2 into 5 by 3. Okay, minus 5 by 3. If you multiply both these, you will get 5 by 6, right? So product of two negative numbers can also result in a positive value, that is 5 by 6. So we don't know if the zeros are exactly positive or negative. Okay, so these numbers can either be positive or negative, but both numbers have to have same sign, right? Because plus into plus gives you plus, and minus into minus gives you minus, and plus into minus or minus into plus just gives you minus. So those are things that we don't want. Okay, so it can either be both zeros can be positive or both zeros can be negative. Okay, so let me just write the factors. 1 by 2 plus or minus 1 by 2 can be a factor. Okay, plus or minus 1 by 3 can be a factor, because these numbers when multiplied with some other fraction will give you 5 by 6, right? And plus or minus 1 by 6 can also be a factor, and you can write for many numbers like that. Okay, let that be that. Now how do we check if these are factors or not? Sorry, how do we check if these are zeros or not? What you are going to do is, you are going to take this number, let us say 1 by 2, and you are going to substitute it in the p of x value. You are going to substitute 1 by 2 in the p of x value. So p of 1 by 2, so that is equal to 1 by 2 the whole squared plus 17 by 6 into 1 by 2 plus 5 by 6. Okay, we are just going to check if this is a 0. 0 in the sense, if p of 1 by 2 is equal to 0, then 1 by 2 is a 0. So 1 by 4 plus 17 by 12 plus 5 by 6. There is no way adding all these positive numbers can end up with 0, right? So obviously 1 by 2 is not a possible value. Okay, now you don't have to erase these things in your paper, you can just leave it there and move on with the next thing. Since space is a constraint for me, I am erasing it. Okay, and the next number that you can think of is minus 1 by 2. Okay, let us do the same for minus 1 by 2. P of minus 1 by 2 is equal to minus 1 by 2 the whole squared plus 17 by 6 into minus 1 by 2 plus 5 by 6. Okay, 1 by 2 minus 1 by 2 squared is 1 by 4 plus, sorry, it would be minus 17 by 12 plus 5 by 6. Okay, now does this add up to 0? We just have to find it out. Let us take LCM. So that would be 12, 4 times 3 is 12 minus 17 plus 10. Okay, so that is 3 minus 17, so that is minus 14. Minus 14 plus 10 is plus 4 by 12. So that is not 0. Okay, so minus 1 by 2 is also not a 0 of this polynomial. Okay, now this is trial and error, right? So you have to keep on doing this to find the right answer. This is not a very good example to solve this problem in this method. Okay, there are other problems for which factor theorem is easier, right? But this is not one of that problem. The method discussed for this problem, which is splitting the middle term, is easier for this. But they have asked us to do this using factor theorem, so that is why we are doing. Okay, so next we have 1 by 3. So just find p of 1 by 3. P of 1 by 3 is 1 by 3 squared plus 17 by 6 into 1 by 3 plus 5 by 6. Okay, now adding all these terms would never get you 0, so definitely 1 by 3 is not an answer. You can try with minus 1 by 3. Okay, so p of minus 1 by 3 is equal to minus 1 by 3 squared plus 17 by 6 into minus 1 by 3 plus 5 by 6. So that is 1 by 9 minus 17 by 18 plus 5 by 6. Okay, finding the LCM to these numbers, the LCM is 18. 9 times 2 is 18 and 17 remains there, and 6 times 3 is 18, right? So 5 times 3 gives you 15. 2 minus 17 plus 15, that is 0. So this is 0 by 18 and hence it is 0. So minus 1 by 3 is in fact a 0 to this polynomial. P of minus 1 by 3 is equal to 0. P of minus 1 by 3 is equal to 0. Now with that, what you can tell is x plus 1 by 3 is a factor. X plus 1 by 3 is a factor of the polynomial. Okay, so you can come to this conclusion. Now what you can do is you can do the same process. You can use these numbers again to find if there are more numbers that are factors of this polynomial. So that is one way that you can do. A simpler way is, we know that AB is equal to 5 by 6, right? We know that, and we have found A to be minus 1 by 3, right? Because minus 1 by 3 is a root. So with this you can find the value of B, right? How do we find? B is equal to AB divided by A. Okay, as simple as that. Now the value of AB is 5 by 6 and the value of A is minus 1 by 3. Okay, so these kind of things we have learned how to solve them. How is that? Let me just move this over here and I'll tell you. Okay, now dividing, if you want to divide it by a division, instead of dividing you can multiply by its reciprocal. So 5 by 6, instead of dividing you are going to multiply by its reciprocal, which is minus 3 by 1. Reciprocal of minus 1 by 3 is minus 3 by 1. So are multiplying by its reciprocal. So that gives you minus 5 by 2, because 3 times 1, 3 times 2 is 6. So minus 5 by 2, and minus 5 by 2 is another root or another 0. Okay, minus 5 by 2 is another 0 of this polynomial. P of minus 5 by 2 is equal to 0. You can just verify that. I'll just do that for you now. So minus 5 by 2 squared, let me just do it quickly, okay, just for verification, right? So minus 5 by 2 squared is 5 by 4, and we are going to multiply with 17 by 6, right? So 17 into 5 by 6 times 2, that is 12, plus 5 by 6. Okay, so the common denominator is going to be 12, and 4 times 3 is 12, so 25 times 3 is 75, plus 17 times 5, what is that? 17 times 5, 5, 3, 5, 85, right? Yeah, so that is going to be, sorry, it's not plus, this should be minus. Okay, minus 85 plus 6 times 2 is 12, so 5 times 2, that gives you 10. Okay, so this is 0 divided by 12. So this also is obviously a 0. This also is obviously a 0 of this polynomial. Okay, so minus 5 by 2. With that you can tell that if minus 5 by 2 is a 0, then x plus 5 by 2 is a factor. Okay, x plus 5 by 2 is a factor, and these are the two factors of this polynomial, x plus 1 by 3 and x plus 5 by 2. Okay, so this is the value of this portion, not the entire thing. X minus a into x minus b, we have found the value for that. Okay, now what you are going to do is you are going to multiply 6 with this, because that gives you the question, right? That is what gives you the question. We have just rewritten it in that form. So 6 into x plus 1 by 3 plus x plus 5 by 2. Okay, I am just erasing these things. I am going to write here. So 6 into, let us just take LCM for here. So that is 3x plus 1 into 2x plus 5 divided by 2, just making it simplification easier. So this 3, it cancelled by 2 and 2 gets cancelled, so it gives you with 3x plus 1 and 2x plus 5. So this is how you factorize this polynomial, and 3x plus 1 into 2x plus 5 is the same answer that we got with the splitting the middle term method. I know this is far harder than that method. It has so many steps involved. So only if you are required to solve it using this factorization method or factor theorem method, only then try to use it. Okay, so I have just explained it elaborately so that you understand it well. Okay, it's not this slow. You'd be probably solving it faster. I just explained it elaborately. So I hope you understood this. There are examples where factor theorem method is faster. Okay, so that we'll be seeing in the next videos. I hope you understood this method. If you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.